In the previous section, we have refactored our functional component to class component and rendered it on the web page. But the web page is still static. That is, once it's been rendered, it remains the same. In this section, let's make it respond to user interactions and change accordingly on the page. To do that, let's discuss about state inside class component. State allows React components to change their output over time in response to user actions, network responses, and anything else. Before starting to code, let's look at this example. This is the one which we are going to build in this section. It's a very trivial example where we have a greeting message hello world with color blue. And when I click on the button, the text color changes to green. If I click on it again, it changes back to blue, and we can continue this. It keeps on changing from blue to green to blue on every button click. This is something that definitely falls into the category of state, as our UI is changing over time with user interaction. Okay, let's head back to editor. First thing that we need to do is to initialize our state object with color blue. To do that, we need to implement a method called getInitialState, which returns an object with initialized state fields. GetInitialState is a lifecycle method which gets called by React automatically, just like our render method. Okay, let's define the method getInitialState. Inside it, I have to return whatever state object or private data that I want to manage inside my component. So I'm returning an object that contains color property initialized to blue. Remember to keep comma between the methods because it's just a JavaScript object. Now, inside render method, instead of accessing color from props, let's take it from the special property state, which we just initialized. Since state is also associated with components instance this, just like props, we need to also access state object using this. So I will access my color property inside state object using this.state.color. Now, our component gets the color from its internally managed state object. So I don't need to pass it from outside. So let's remove this part. Okay. Finally, let's add a button click me. I'm going to add it right down here after div. Since if I add it inside of my div React element, then color style will be applied to button also, which I don't want. Okay, I'm going to create a button with name click me. In our earlier discussion, we mentioned that when we want to return multiple React elements from our component, then we have to wrap them inside a top level div, so that we will return only one JavaScript object of type div from the method. Otherwise, it's an error, since we can't return multiple elements or objects from a function in JavaScript. So let's wrap these things in a container div or div React element. Okay, let's save it and head over to the browser. And we can see that color of greeting message is blue and we have the button click me. But when we click on the button, nothing happens because we haven't written any logic for handling the button clicks. So let's quickly head over to the code editor and handle button click event. To handle the button click event, we need to pass a callback method to the button's onClick property. So over the button element, we can say onClick equal to. Notice here it's not small letter C in our onClick, which distinguishes it from actual HTML button click event. This you can consider as wrapper to our actual onClick event of DOM. Okay, we are gonna assign it to the callback method handle button click, which we will be defining it in a moment. Since it's a method inside the object, I have to refer it using this.method name. So it will be this.handle button click, kept inside braces because it's a JavaScript expression inside JSX. Okay, now let's implement handle button click method. And let's keep a comma over here between the properties. Fine. There are two things that we want to do inside handle button click method. First, we want to update the state field color, and second, we want to trigger the re-render of whole component. That is, we want our render method to get called again, so that the change to color property of state gets reflected on the web page. To do that, React provides us with a method by name setState. Calling setState triggers a re-render with the new state that we will be returning from it. So I can say this dot setState and pass it an updater function as its argument. Updater function expects previous state and props as its arguments. But since we don't have any use for props inside the function, I'm not going to mention that as second argument. In our next pet game app, we will have an in-depth discussion on functionality of setState method and its two variants. One which accepts object as its argument and the other that accepts updater function as its argument, which we are using now. Okay, you can think of this previous state as the current state inside the component. Let's actually log previous state to the console. setState method expects us to return the new state object. So for now, just return the previous state itself. Okay, let's save it and head back to the browser to check our log on console. Click on the button multiple times and we get our log printed for every button click, which is showing state object. Okay, I will explain the behavior, what's happening inside the code, as understanding this flow is crucial for the class component. Firstly, I initialized state object with color property inside it. And when our component gets rendered on the UI, it applied that color to the greeting message, hello world. Then upon button click, it triggered the handle button click callback method. And we have called setState inside it, which printed our log. Okay, one important thing to note here is, whenever we call setState, React thinks that we are gonna update our state object. And so, irrespective of whether we change the state inside it or not, it's gonna trigger re-render. I mean, it's gonna call our render method again. To prove this, let's add some log inside our render method. Inside render, and let's print color property inside our state object. This dot state dot color. Okay. Let's save it and check it on the console. Let's click on the button a few times. See, every time I click on the button, it's printing the log inside render blue, which proves that our component gets re-rendered upon setState call. This log at the top is for initial render of the component. Okay, but since we haven't changed the color yet, it's gonna show us the same color over the greeting message. That's why we didn't observe any difference on the UI. Alright, let's toggle the color now to observe the change. Let's remove the code inside setState method. And let's return an updated state object containing the color property set to. Now we will check the previous color value and toggle it accordingly. I'm gonna use the JavaScript conditional expression here. I'm gonna check the previous state color. If it's equal to blue, then I'm gonna change it to green. If it's not, then it will be blue. Okay. If the previous state color is blue, then our color field is set to green, else it will be blue. Let's save it and head back to the browser to verify if everything works fine. Let's click on the button. Greeting message turns green. And as we click on it again, it turns blue. Let's repeat it a few times. Perfect. We can also see the log messages on console, indicating the color applied for every button click. Okay. This is how state and setState are very useful inside our class component. State is useful to store and manage the private data inside the component. And setState is used to trigger the re-render of component with the updated state object. One thing I have to point out here is, you may think like rendering our whole component every time for a change inside the state object can be a performance penalty, right? But it's actually not, thanks to Virtual DOM. This is where React gained its upper hand over its competitive frameworks. React is not a framework though, it's just a library. We will discuss more on what's happening behind the scenes when we discuss reconciliation and how it improves the performance of our React application. For now, let's limit ourselves to understand the fundamental concepts and basic terminologies in React. And let's get familiarized to them by building some applications at first. Okay, let's discuss one last point before we wrap up the discussion here. Difference between functional component and class-based component is same as of the difference between function and an object. A function just takes an input from the caller and returns an output. This is exactly what a functional component does. It takes props as input and returns some JSX or React element as output. Even though functions are building blocks of any program, they themselves are alone. For example, if I have to manage an employee database, I need to create the records and update different sections of records over a period of time. Now, in this scenario, function is not enough to handle employee records, as I have to bind the data of employee and its associated methods also. I can separate employee data and write multiple functions operating on those data, but I lack some kind of glue that binds them. This is where object-oriented programming really shines. Object-oriented programming allows us to bind the data as well as methods operating on those data together. So I can keep my employee data, methods to create and initialize employee, update employee data, etc. all inside an object. You can think of object as a group of functions or methods that operate on their own data. So if you look at our functional component, it is very much limited. It can only accept props which can't be mutated and return JSX. We can't associate any state inside the function that can change over a period of time. That's a restriction, but it can also be considered as a kind of simplicity. So depending on the use case, whether you need to tie up some data with the component or not, you can choose to use either a functional component or a class component. That's why two types of components exist at the first place. But sometimes simplicity may not be enough. Web applications need to be dynamic these days and maintain their own data. Like app bar is open or closed is a state data inside it. Suppose if we have multiple shows and which show we want to render on the web page is decided by state inside the component. So in these cases, we need methods like render, which does the role of functional component. Finally, to put it in short, the difference between functional and class-based component is same as of the difference between function and an object created from the class. Okay. Now that we have an idea about props, state and set state inside our class component, it's time to build very trivial shows application in the next section. Alright, let's continue.